Hello everyone, welcome to the GeoEcologist. I'm Dr. Krishnanand and you have been watching my videos on various topics of geography, environment and research methodology on my channel, The GeoEcologist. If you're a new subscriber, please go to our playlist section and see the earlier videos. Now, in this series on hydrology, we're going to talk about today that is the systems approach in hydrology. So what is the systems approach? What is the input-output model? And also at the end, we'll be talking about the interruptions to hydrological behavior. And all these things are going to be very important. So please watch the video till the end because it's going to be interesting. So now let's go ahead and learn. But before going ahead, don't forget to share these videos with others. And also please do subscribe, comment, and like these videos because this helps us in increasing our outreach. So now let's learn. So now let's understand and learn hydrology's systems approach. And also we'll be looking into the input-output model and interruption of hydrological behavior at the end of this lecture. So now it's very important to understand that whenever we say systems approach, what does a system mean? So you take any system, if you talk about our body, human body has circulatory system, respiratory system. So wherever the word system comes, the first thing to understand is that system is actually made up of components. So if you need to understand the systems, you need to understand its components. So what are the components of hydrology and how they together work, right? It means that how one component of the hydrology is linked to the other component. So here comes the word linkages, right? And alongside that, you call it functioning. So what you observe, whenever we talk about systems approach, you need to understand the components, you need to understand the linkages between those components and how do they function together. It means that if there is some system which has different components, so each component is linked to the other, and if there is change in any one component of the system, the all others will get affected. Right? So this is the basic understanding of systems approach. And further, we'll be looking into the input-output models and also hydrological behavior in which what kind of interruptions are we causing. So let's understand now. So the first thing that you observe is that who gave this idea of systems approach and where is it originating from? So if you observe the input-output system theory, also known as systems theory in simple language, is basically originating from 1930s, 1936 with biologist. So you understand this concept was coming from biology. So this biologist Ludwig von Bertalanffy and was further developed by Ross Ashby and George Bateson. So who was this Carl Ludwig von Bertalanffy? He was basically an Austrian biologist and known for the foundations of general systems theory. Now this general systems theory, if you observe later on, Immanuel Wallerstein, if you observe, has also worked on it. So many scholars in different subjects have used this systems theory. Why? Because it helps us to analyze and understand the highlights of real systems, which is open and also interactive in their environments and many times also closed. So if you want to learn about the systems and how they develop new properties through emergence and leading continuous evolution, you need to look into this. So how this entire water cycle and the systems that we operate on the earth in terms of hydrology operates. So now let's understand that what is the systems approach talking about. So systems approach to hydrology is basically a holistic methodology. Understand this catchword here. Wherever you use a holistic, it means it's inclusive. The first thing with holistic is it has to be inclusive of many things, right? It will cover overall scenario, right? It will have multiplicity, right? Holistic is always multiplicity involving, right? It doesn't mean singlistic. So holistic involves everything. It takes care of everyone. So if you are having a holistic perspective, it means you'll be looking into variety. So this holistic methodology is what we call a systems approach methodology that views hydrological cycle, the famous water cycle since childhood we have been studying, as a complex system with interconnected components and processes. Understand this catchword here, interconnection, right? So interconnected components and the processes are the basic keyword here to understand. So instead of analyzing individuals, like say if we talk about only clouds or for that matter only oceans or solar insolation, it will be individual. So instead of analyzing individual aspects of water cycle, like say insolation, the systems approach considers interaction and interdependencies. Now, these are the keywords. Why am I highlighting these keywords? Only to, memorize, engrave in your memories that these keywords have to be written in your answers whenever you're using it. And before, you need to understand all these elements clearly. So precipitation, evaporation, runoff, infiltration, underground water flow, surface water flow, all these are basically components and they are interlinked, right? So they're interconnected and they keep operating. To understand this, holistic methodology is needed. That's why we have this systems approach in hydrology. Now let's understand the need for systems approach and establish it properly and understand it. So the first thing is that in systems approach, it helps us to gain the big picture. Now, when I say big picture, what is this big picture? The big picture is the world system, right? The earth system. So systems approach to hydrology looks at entire water cycle as a big interconnected system instead of just focusing on individual parts like say rain, river, etc. Now, it is very important that how we see things. So see how things get connected. It means it may look like a giant puzzle to somebody, but you need to understand how each component fits together. So this approach helps us in better understanding, better clarity. Third important thing is we learn from the nature. So we take inspiration how nature works as a whole system, right? We cannot bifurcate nature into singularities, right? It's a multiple system that operates together. So that's how plants, animals, environment all depend on each other and each have an important role to play, right? The ecological approach, we say, and bringing together different ideas. So this is the holistic idea that we are talking about, that systems approach combines ideas from different subjects like from science, maths, even engineering, and bringing these ideas together. When we start doing locational analysis, right, or say mapping, then it becomes geography, right? So look into this holistic perspective here and interdisciplinary perspective here. So if you look here, then the last point, if you observe here, this is making smart decision. How will you make a smart decision if you don't understand the big picture? Right. So when we understand the whole water system, it's easy for us to understand carefully and make better decisions related to water conservation, management of floods, right? This helps us protect our environment and make sure that we have enough water for everyone. And water scarcity is a big problem these days. Everywhere it's being talked about. So looking at the future, right? Looking at sustainability of the future, systems approach is very important because it helps us also to gaze into the future, predict how changes will happen. Simulation modeling happens, right? So we need to look into what will be the situation in 2050, what will be in 2070, or end of 21st century. This is what we talk about. So climate change and all those analysis that we see where we talk about sustainability of our planet, remember systems approach is the key. So that's why we established the need for this approach. So now if you look into further, overall, the systems approach to hydrology helps us to see and gaze big picture how water moves. Now, if you observe here, global per capita water availability map, this is the overall picture of a world. And you see what's happening. Which country is having the maximum per capita domestic water usage? Please check United States. Then you have Brazil. Look into Germany. Look into the comparisons and where is the development leading to. If you observe here, Middle East, South America, Europe, Central America, Asia, Africa, Oceania, and North America, where you have per capita water usage maximum, here is North America. Right. So this water infographic gives us a big picture, and this is what we talk about the big picture. If you look into these areas, the reddish areas, the yellowish areas of the world, including India, where we are, you see scarcity of water. Per capita water availability is very low. So it's like solving this big puzzle. How will you solve this puzzle? Unless you know the systems approach. So we can make smarter decisions about future and about this water protection, or you can say availability and also conservation. Until we don't have the systems approach, it will be not easy for us how one is connected to the other. So the systems approach came to geography in 1960s, 70s, and it was very important to look into the linkages between these drainage basins and how systems operate in water cycle. So drainage basin as a system has been studied by many geographers. Especially we say this is fluvial geomorphology, where it operates. Right, so you'll see in 60s and 70s a lot of fluvial geomorphologists operating with sciences and also interdisciplinary approach using stats. Right, it was the phase of quantitative revolution in geography, where a lot of statistical methods of measurements of this input output and all these modeling were invented, and it was talked about. So moisture loss to sediment flow to all these things were talked about. Now, water's journey. How do you understand water's journey? When water starts its journey in the basin from a raindrop hitting the soil, and how it reaches to the streams, and how gully erosion happens, how plains are created, how delta is created, and then finally water meets ocean. This entire system has been mapped. And here you will also look into input output system, where in river basin, what is the input of the water and how the output goes. So this linkage is also very important, right? And then finally, the value of systems approach, right? So the systems approach in hydrology allows quantification, the measurement part, the science part, and also alongside it includes the characteristics like shape, social impact, physical features. All these things are to be looked into, right? So instead of breaking down into different components, like in human body, we have different organs or cells, systems theory focuses on how these parts are organized, right? So look into the water cycle. This is how we say organized. So we have condensation, precipitation, evaporation, infiltration, right? You see these words here. These words are the keywords carefully. So for instance, in the context of water cycle, system theory emphasizes the arrangement and relationship between these elements, right? You see these elements and how they are arranged. So you can draw this diagram for yourself with a common diagram. So here, according to Cam King in 1966, system can be defined as collection of objects that are studied together in simple language with their relationships and individual attributes contributing to the system. So this is called interconnected system, where one component is as important as the other component, right? The role of every player in the system is important, remember, right? And no single player can announce that I am the system myself, isn't it? So what you observe, the hydrology and input output system. So if you say this is the system, if you input rainfall into the system, which has temperature, humidity, slope, and geology, the output would be evaporation and runoff. This is a simple model to understand this. So understanding these drainage basins are very important. And in the lectures to come, we'll be talking more on drainage basins, because that was the building block of this input output model and system model. So drainage basin is like a bowl, right? Where all the water from the rain, snow, hail, dew gathers. So understand this is the area where all the water is gathering, and then it's moving towards the mouth, right? So this is something which is very important. So this is input, and this is the system, and this is the output, right? So if you observe here, input and output model, if you observe, is very important to understand. So precipitation is the main input, if you observe, right? And including rain, snow, hail, dew. And output includes evaporation, transpiration. These words, if you have not heard before, please take our climatology lectures, right? And evapotranspiration. So this is what we call as output. It's going back to this, right? And this is what we talk about. And here, another output, if I say, is river discharge, which I talked about here, right? So we'll be also talking about the discharge quantification measurements in the lectures to come. Now, there is very important to understand that systems will have boundaries, and these boundaries will make them unique from the other systems, from the surroundings, right? Do you see this image clearly? This is a schematic image telling us this is the system, and this has its boundary, its limits. So concept of system boundaries is crucial, very, very important, right? Why? Because we need to understand how these different systems operate, right? In particularly natural environments. So these boundaries that we delineate, this line that we draw is called delineation, right? It sets the limits within which system will function. Unless we have this understanding, we cannot clearly say what's happening in the system. So some boundaries, for example, changes in vegetation density with basin area, if you observe, may be less distinct and transitional. And on the opposite side, boundaries like division between urban and rural is more clearly defined. Right, so you observe the urban systems and rural systems, and there is also transition zone between them, right? Rural urban fringe. So if you apply this concept, it's the same again we talk about. So there are different kinds of systems based on the how interact with the surroundings. So one of them, if you observe, is open system. You see the energy is getting transferred from inside and outside, and matter is also going outside and inside, right? This is called open system. In closed systems, only incoming and outgoing of energy is there, but remember, matter does not. right? And in isolated system, if you observe, energy is coming in, matter is coming in, but it's completely closed. It's not going out. So open systems, remember, open systems freely exchange both energy and matter, material, right? Examples include drainage basins and lakes, which receive, right, water from precipitation and river and lose water through evaporation, human consumption. Come to the closed systems, and closed systems exchange energy through evaporation but not material across their boundaries. So global water cycle is an example of closed system. Why? Because here, as total amount of water on the earth remains constant relatively, isn't it? And then what you observe is isolated systems have no exchange of energy or material within their surroundings, so they are fixed inside. So if you observe in control laboratory, if you do work, this is like an isolated systems approach. So in summary, if you want to understand, the system boundaries are very important for understanding this particular types of system. Now what we observe further, that let's look into our own hydrological cycle and observe how it is a closed system. So if you look into these phenomena, water is neither created nor destroyed on a large scale. It continuously circulates, right, through various phases from solid, liquid to gases, right? And the processes like evaporation, condensation, precipitation, runoff, infiltration is what we talk about, these processes in the closed system, isn't it? So if you observe, what is the significance or importance of hydrological cycle as a closed system? First importance is the water balance maintenance on earth, right? In a closed hydrological system, the total amount of water on earth remains same over time, and water is continuously recycled. It means the constancy is maintained, the balance is maintained, right? It's not lost to the space. Now continuous circulation through evaporation, condensation, precipitation, runoff, and infiltration, mark these keywords. This is how it is continuously changing forms. So formation of clouds, going back to the rain, and again going back to the river, and again evaporating. These processes continue. And reservoir and distribution. So hydrological cycle involves movement of water between reservoirs like oceans, lakes, river, glaciers, and groundwater, right? Isn't it? So if you directly put ocean water into the groundwater, it will not be working out. But this is a very interesting natural system that operates within that and also helps us gain our livelihood through this, through our life through this, isn't it? So because human life cannot sustain directly on ocean water, so that's why you see this entire cycle helps us in, gaining that water, which is fresh water. And where is the fresh water coming from, right? So it's actually redistributing, right? So that's very important to understand. And further, the stable environmental equilibrium, the balance, right? So the equilibrium is very important, and environmental equilibrium is maintained by sustaining water resources, supporting ecosystems, and it ensures that essential water sources are replenished, right? Recharged naturally, preventing shortages or excess. But there are interruptions, which we are going to talk about. So the next importance is sustainability and life support. Remember, sustainability principle, we need water. Look at India's drainage and river basins, right? And where is the maximum population thriving? So this is the biggest river basin. If you observe the Ganga river basin, here is the Indus and its tributary river basin in this side, and here is Brahmaputra in the North India. Then you have Mahanadi, Narmada, and Tapi. Then you have Krishna, Pennar, Kaveri, right? Palar. Look at this. So if you observe so many river basins, and these are supporting us, right? Our life systems. That's why we are one of the most populous countries in the world and the most civilizations that have come up, right? Observe what we have done, our cultures, our religion, right? So many things have come up from here, this life support system and sustainability, right? So this is important. And then global connectivity, right? So despite localized variation, hydrological cycle operates at global level. It's not just your system, it's a global system, right? So these local, regional, and global are interconnected, right? So the weather patterns, climatic zones, right? All these things are important. And environmental regulation, stabilizing climatic conditions, temperature, humidity, weather patterns, and distributing heat across the planet. Water is very essential, as we know. So now, at the end, let's talk about what is this interruption to hydrological behavior. So interruptions to a hydrological behavior in simple language refers to these disruptions or changes in the normal pattern of operation. So if this process that is operating in normal pattern, if it is interrupted by something which is, let's say, a natural or say human induced factors, understand this very important point here, that it's leading to alterations in the quantity, quality, timing, and distribution. The words are very important here: quantity, quality, timing, and distribution of water resources. So, some common interruptions to hydrological behavior would include the first, that is very common, the buzzword climate change. So changes in temperature, precipitation, humidity, right, overall for a long term at a place. This is one interruption. This may result in altered rainfall patterns, as we are looking into extreme events that are triggered around the world, cloudbursts and everything that we see. Land use changes like deforestation, urbanization, agriculture expansion, reckless cutting of trees, removal of vegetation. Right, you see what's happening. Infiltration rates are getting reduced, water table is going down, right? So these things are very important here. Water pollution, of course, so contamination of water bodies. And look into what's happening: impairment of water availability for drinking, irrigation, industrial usage. And that's where ecological and socio-economic crisis also related to this happens. Right now, water extraction, this is a big problem, especially in context to India. We use 80 to 90% of water from the groundwater or the river water for irrigation, agriculture, right? And excessive withdrawal of water from river, lakes, aquifers for agriculture or industrial or any other local municipal usage deplete water resources. And if enough is not recharged, it is over extraction, right? So this is where we're leading it to reduced stream flow, ecological degradation, and affecting both us, human systems, and ecological systems that we take overall. Coming to dams and infrastructure, the construction of dams, reservoirs, and all those water management structure that we create. Remember, these hydrological processes, natural processes, are obstructed many times, right? So there are benefits, of course, but then they are also disrupting downstream ecosystem. So there have been rivers which are now completely dead. So what is a dead river or stream? Where you create a dam, and this is the river, and if you go to this place, there is no water, right? It has been all channeled to the dams. So this is something which is very important. It's hampering the life, right? So we need to be very clear about what we are creating and what is it going to get, the impacts, right? Now, hazards and disasters, of course. So you have seen several hazardous events: floods, droughts, hurricanes, earthquakes, and also leading to this particular disasters at places where we have more vulnerability, right? So this can result in catastrophic damage to infrastructure, loss of life, and significant disruptions to water supply and sanitation systems. Coming to the next is glacial retreat, which is getting very common. So look into Alps, look into Himalayan region, look into polar areas. What is happening to the glaciers? It's retreating, it's reducing, and it's impacting obviously the downstream and water resources and our ecosystem. So these are the interruptions, right? We need to look into it. And of course, after looking into the system analysis of hydrology, we can understand and highlight these complex interactions. Otherwise, we cannot how one is related to the other. And this is very important for us to look into these human factors which are shaping these water resource management and sustainability to mitigate these particular problems. So interruptions to this particular cycle or water cycle, or you can say overall this entire water system on Earth, is what we're talking about here. So it's going to be very important. So please do like and subscribe to our channel, and please don't forget, share these videos with maximum outreach, please. So now we meet for the another video on hydrology, and stay tuned. Please keep watching and do subscribe, and please do share these videos more and more, and help us in creating a huge video library related to these important topics which are relevant across the world and India. So see you, take care, bye-bye. Hello and welcome to the GeoEcologist. We are an online platform for all geography courses including UPSC, UGC NET and others. Do enroll at TheGeoecologist.com. We have UPSC Geography optional course both in English as well as bilingual. We have UGC NET JRF Assistant Professor course both in English and bilingual. And if you want to check these courses, go to our website where all these courses are listed, and you can click on the course info where all the details will open up on our website. So there you can see all the details, course highlights, and all the details that you require to take the course. And also in orientation program Story of Geography, you'll find the free videos before taking the course. You can click on these videos and watch it for yourself. And also when you take the course, then you can go to the dashboard, and where in your enrolled courses you'll find your course activated after you have bought the course. So all the best wishes to all the learners, aspirants. Connect with us if you have any query. Best wishes.